Viewers, welcome back. Amos Tekuma Agbe is still here, and today we are solving a past question from JAMB 2019, question 15. The question says, what volume of oxygen will remain after reacting 8 cubic cm of hydrogen gas with 20 cubic cm of oxygen gas? We should take the possible options: A, which says 10 cubic cm, B, 12 cubic cm, C, 14 cubic cm, and D, 16 cubic cm. Viewers all over the world, this question is coming from Gay-Lussac's law, which describes the combining volume of gases. Now, Gay-Lussac's law states that when gases react, they do so in volumes which be a simple ratio to one another and to the volumes of the product if gaseous, provided the temperature and pressure are kept constant. Now, according to Gay-Lussac, if for instance 2 mole carbon monoxide react with say 1 mole of oxygen gas then the volume ratio can be stated as 2:1:2. Now we're going to use this law to answer the question above. The question says, what volume of oxygen will remain after reacting 8 cubic cm of hydrogen gas with 20 cubic cm of oxygen gas? Now, the first step to solving this kind of question is to write a balanced chemical equation of the reaction between hydrogen gas and, of course, oxygen gas. So let's see the equation. Now from here we can see that hydrogen gas is reacting with oxygen gas to give us water vapor. Now this is a chemical equation representing the reaction between oxygen gas and, of course, hydrogen gas. But this kind of equation is not balanced. Now from this is the reactant side, this is the product side. 2 atoms of hydrogen react with 2 atoms of oxygen to give us water vapor. Now let's check the number of atoms of hydrogen from the reactant side and, of course, from the product side. Now from the reactant side we can see that there are 2 atoms of hydrogen, and of course from the product side there are 2 atoms of hydrogen. So for now hydrogen is balanced. Now let's check for oxygen. From the reactant side there are 2 atoms of oxygen, whereas from the product side there is just 1 atom of oxygen. So oxygen is not balanced. How do we balance oxygen? Very simple. We're going to introduce 2 here. We're going to introduce 2 there. Of course, we have done that. So we have 2 atoms of oxygen from the product side and, of course, 2 atoms of oxygen from the reactant side. So oxygen is now balanced. But this 2 now is affecting hydrogen. From the product side we have 2 times 2, which is 4. We have 4 atoms of hydrogen, and of course from the reactant side we have just 2 atoms of hydrogen. So we need to balance hydrogen too. And how do we do that? We're going to introduce 2. We're going to introduce 2 here. So from the reactant side, so we have 2 times 2, which is 4. So we have 4 atoms of hydrogen from the reactant side, and of course 4 atoms of hydrogen from the product side. So hydrogen from both the reactant and product side are balanced, and of course oxygen atoms from both the reactant and from the product are also properly balanced. So this is the balanced chemical equation representing the reaction between hydrogen gas and, of course, oxygen gas. Now according to Gay-Lussac, that means 2 volumes of hydrogen gas will react with 1 volume of oxygen gas to give 2 volumes of water vapor. In essence, 2 cubic cm of hydrogen gas will react with 1 cubic cm of oxygen gas to give 2 cubic cm of water vapor. So now 2 volumes of hydrogen gas react with 1 volume of oxygen gas to yield 2 volumes of water vapor. Now we will have to relate this mathematically to see that medium of hydrogen gas will react with 1 cubic cm of oxygen gas. So we have 2 cubic cm of hydrogen gas reacting with 1 cubic cm of oxygen gas. Now the question says we should find the volume of oxygen that will remain after reacting with 8 cubic cm of hydrogen gas. What then will be the volume of oxygen gas that will be used up in the reaction between hydrogen gas, 8 cubic cm of hydrogen gas? That is, what will be the volume of oxygen that will remain after reacting 8 cubic cm of hydrogen gas? So let's find the cubic cm of oxygen gas that will be used up in the reaction between 8 cubic cm of hydrogen gas. So if 2 cubic cm of hydrogen gas react with 1 cubic cm of oxygen gas, 8 cubic cm of hydrogen gas will react with an unknown cubic cm, unknown volume of oxygen gas. So we don't know the volume yet, so let's call it X. So how do we find X? Very simple, by cross multiplication of this. So once we do that, we're going to make X the subject of the formula, and our X will be equal to So we have done that. So our X now will be equal to 8 times 1 is T1, of course, divided by 8 times 1 is T8, and of course we have 8 dividing 2, that will be 4 cubic cm. So our X is equal to 4 cubic cm. That means 8 cubic cm of hydrogen gas will react with only 4 cubic cm of oxygen gas. Recall that the total volume of oxygen is equal to 20 cubic cm. So to find the volume of oxygen gas that will remain after reacting with 8 cubic cm of hydrogen gas, we're going to say that we're going to subtract the volume of oxygen gas used, which is 4 cubic cm, from 20 cubic cm, which is the total volume of oxygen gas. So to find the volume of oxygen gas remaining, we're going to subtract the volume of oxygen gas used up in the reaction from the total volume of oxygen. But the total volume of oxygen from the question was 20 cubic cm. So we're going to see that 20 cubic cm minus 4 cubic cm. So 20 cubic cm minus 4 cubic cm, we have 16 cubic cm. And this is our final answer. So the correct option from the options we have here is option D, which says 16 cubic cm. And we're done with that. This is a past question from JAMB 2018, question 15. If you're interested in this kind of videos, don't forget to like and share. Also subscribe to my YouTube channel, Amos-T Online Class. Follow me on TikTok, Amos-T Online Class, and of course on Facebook, Amos-T Online Class and Amos-T Kumangbe. Thank you for watching and God bless you. See you in my next video. Bye.